As we begin chapter 14, we're going to be graphing trig functions. We'll start today with the sine, the cosine, and the tangent functions. So what we're going to do is we're going to plot values for the sine function by figuring out what the values are for given angles, and we're going to do these in radians, so we're going to get really good at graphing with radians. So the x-coordinate is going to be angles in radians, and then the y-coordinate is going to be the sine of whatever that angle is. So remember, if you have a little unit circle that looks like this, okay, we want the sine of the angle, so that's going to mean the vertical distance, so the y coordinate, okay, that's going to be the sine anywhere on the unit circle. So if we choose an angle like 0 degrees, the sine of 0 is going to be 0. Now the sine of pi over 6, which is 30 degrees, hopefully you remember, the sine of pi over 6, since that's a 30, 60, 90 triangle, it's going to be the short side, so that's going to be 1/2. Or we're going to put it in decimal values, that's going to make it a little easier to graph it. Okay, pi over 4, that's 45 degrees. The sine of that is square root of 2 over 2. In our calculator, we can figure out that that is 0.707. Pi over 3, the angle pi over 3, that is 60 degrees. The sine of pi over 3 is, that's going to be the long leg of a 30, 60, 90 triangle, so it's going to be the square root of 3 over 2, or 0.866. Now, you can play around with your calculator now, get it into radian mode, and you can try finding the sines of these different angles. So get your calculator into radian mode, plug in pi divided by 2, and then take the sine of that, and you can figure out these values. So what I suggest you do now is pause this video and then fill in the rest of the values, at least for the first column. Populate all of those values, and then we're going to go ahead and graph it. So go ahead, pause the video, and populate those. Okay, so I'm going to keep going now. I find the rest of the values for the sine of the angle, given an angle. Notice I start at 0, okay, so when I'm right down here, when I have an angle of 0, I have a sine of 0, because the y-coordinate is 0 here. When I go all the way around, I end up back again at 0. So that's what's going on here. We have a 0 over here, and then we have a 0 again at pi. Okay, so we're going to go ahead and graph those. Now, part of the hardest part of graphing trig functions is figuring out how you're going to label the axes and figuring out the fractional values. That's really challenging for students. So the way we have it set up here, pi over 2, you can break that into 3 chunks. That would be pi over 6, pi over 3, what is 1 pi over 6, 2 pi over 6, and 3 pi over 6 is, 3 pi over 6 is the same as pi over 2. So you can label each tick mark with a pi over 6. So I'm going to go ahead and do that, label all the tick marks on my graph. That's going to make it easier for me to plot the points. Now, one of the tricky things, though, is where am I going to put my pi over 4s? Where do those go? Okay, pi over 4 is going to be 45 degrees, which is half of 90, right? So pi over 4 is going to be halfway in between 0 and pi over 2. So we can make a special tick mark right there, and I've done these in orange. Okay, so now once I have my graph labeled, and I have my data points, so I plugged in the angle, I got the sine, now I'm going to plot those points on my graph. So I'm going to go 0, 0 is going to be my first point, and then I'm going to go over to pi over 6, and it's going to go up 1/2, and then I'm going to go pi over 4, and that's going to go up 0.707, then I'm going to go pi over 3, 0.866, and then pi over 2 up to 1. So I worked my way up to the top. Now it's going to drop back down again, because now I've gone from, I just did this side of the circle over here, and now I'm going to move to the other side of the circle going down. So my angles are going to go from pi over 2 to 2 pi over 3, 3 pi over 4, etc. So let's go ahead and plot all those points, and we drop back down to 0. Okay, so like it climbs up a mountain, it comes back down to the valley below. Right now we're going to go ahead and figure out the function values for the rest of our angles. So starting with 7 pi over 6, and then 5 pi over 4, 4 pi over 3. You might want to refer to one of your unit circles to find the values for the sine, or you could use your calculator. But now you want to figure out what are the sines of these various angles. So I figure out what they are. Go ahead and pause the video and figure them out, and then I'll go ahead and write them out and plot them. So negative 0.5. Notice the signs are going to go negative now because we're now in this portion of the unit circle. So now our signs are going negative because our y values are negative. We get the same types of values we had before, except we have the negative versions. So now we're going to plot those points, and we see that the curve looks really similar to the first part of the curve, except it goes underneath the x-axis. Okay, so we climb a mountain, then we drop to the valley, then we go down a huge valley and come back. Okay, so that is what a sine function looks like for the angles between 0 and 2 pi. Let's look at the cosine function. We're going to do the same thing we did before, except I've chosen many fewer angles. Because once you've done one sine function, you realize how similar any other ones are going to be. So I have 0, pi over 6, pi over 4, pi over 3. I want to find the cosine of those angles. So once again, I just start with a little unit circle and think about what's going on. At 0, at x equals 0, right, a 0 degree angle, or 0 radians, the cosine is going to be 1. Because that's going to be the x value, the x coordinate. So cosine is 1. At pi over 6, that's 30 degrees. The x coordinate is going to be square root of 3 over 2, or 0.866. Pi over 4 is 45 degrees. That's going to be square root of 2 over 2, or 0.707. Pi over 3 is 1/2, etc. Okay, then I stopped going for the little medium angles. I just went for pi over 2, and then pi, and 3 pi over 2, and 2 pi. So I didn't plot as many points for the cosine function. Let's see what happens if we could